Well, I managed to skip out on the introduction real quick. Are you going to set the timer? Oh, there we go. So the time, we have a timer up here, so I'm down to, I've only got 5 minutes, right? And I'll keep to that. But I skipped out on the introductions just briefly because I figured why repeat myself. So I'm Jeff Basara. I'm at the University of Oklahoma here. I'm an associate professor in the School of Meteorology, and I'm also an associate professor in the School of Civil Engineering and Environmental Science. I serve as Dr. Yang Hong mentioned, the Hydrology and Water Security Program. I serve as the Executive Associate Director there. And I'm also the Director of the Kessler Atmospheric and Ecological Field Station. All that's to say, I have a lot of titles. I can assimilate them, but I can't seem to assimilate paychecks. That's a joke, of course. I'm very happy. I will say this, a little bit about what we do in my group is we focus, I lead what's called the Climate Hydrology Ecosystems Weather Group. We call ourselves CHUI. That I can thank my graduate students for that. They didn't like the Weather, Climate, Water Ecosystems Group. There's no good acronym for that. So, but we pick projects that we work on from both local, and that means it's sort of in the region of the Southern Great Plains and expanding out to global, of projects that often integrate between all four of these areas. In fact, we won't take on any project that doesn't have at least two in them. And so this is an important aspect of what we do. I lead a sort of a 7-member group of number of PhD students, MS students, and a research affiliate, but also obviously collaborate with many people both in this room and in this group, and certainly under the umbrella of the Hydrology and Water Security Program that is really emerging right now, also with the Oklahoma Water Survey. And obviously, some of our real important topics that we sort of address are excessive precipitation and flooding, drought development, intensification, and persistence. We look at the flux of water vapor and carbon and the ecological aspects of these larger scale environmental impacts. How does that impact ecosystems? And we monitor those in real time at many locations in the Southern Great Plains. And we look at this interrelationship between the surface and the atmosphere and coupling from both local to global scales, trying to address water-related issues as a function of weather and climate. I'll just show a couple of images here. This is what we work on. So in 2014, we had significant drought across the Southern Great Plains. This was sort of the end of a 4-year drought. This is what the ecosystem looked like at the Kessler Field Station, which is just southwest of Norman. The water quality, or the water availability in this particular flood control device and stock pond was quite low. The ecosystem looked pretty, pathetic at that point in time. However, excessive precipitation that occurred the following year, if you could say an ecosystem looked happy, this is what it would be like, right? Look at how green and lush it is. The water quantity has actually increased significantly in the surface water, but then at the same time, water quality has decreased because of all the excess runoff. And these are driven by these rapid transitions that we are seeing and seeing more frequently in the Southern Great Plains of the United States, from drought to what we call pluvials and then backwards. In fact, many of our long-term features in terms of decadal droughts have ended with these rapid transitions from wet to dry, but we also see that there are cases where we can actually go from the opposite. So this is a case where the ecosystem is looking particularly good, and then it is followed by the rapid desiccation of the land surface within just 45 days because of really rapid intensification of drought in the region. And so what we are faced with here in the Southern Great Plains and the continuing research that my group is doing is looking at these transitions specifically of wet to dry, dry to wet, because we never stay at normal. And we are transitioning faster than ever here in the Southern Great Plains. And this obviously has huge impacts on water resources and agriculture. And every stone we unturn shows that the variability in magnitude, timing, and intensity of precipitation and precipitation extremes is increasing in this region. So when we look at the long-term future of the Southern Great Plains, from all other aspects that depend on weather and climate variability and ecosystems and agriculture, we need to put all these things into proper context. So that's what my group works on. If you're interested in any of those things, please come see me. I'm happy to chat. I lead this group, again, the CHUI group embedded underneath the Hydrology and Water Security Program here at the University of Oklahoma. 5 seconds.